Okay, BC Unit 2, Day 3 assignment on the book, page 84, 111 odd, 1923 all, 2829, 4750 all, 5659 all. So let's do some of these. So the first 10 problems say define points of continuity, find the points of continuity and the points of discontinuity of a function. Identify each type of discontinuity. So, number 1 over x plus 2 squared. Division by 0 is going to be a vertical asymptote, so x equals -2 is the location of the discontinuity, and the type is infinite discontinuity. So location and type. 3, y equals 1 over x squared plus 1. You can't make that equal to 0 because it's imaginary. So no points of discontinuity. 5. Y equals the square root of 2x plus 3. So the inside has to be greater than or equal to 0, which means that the graph is defined for that. Find the points of continuity and the points. So essentially, any points of, this is where it is continuous. So x is less than -3/2 is where it's not in the domain of the function. Okay, 7, y equals the absolute value of x over x. Now, what happens on this graph, when x is positive, it's equal 1. When x is negative, it's equal -1. So the graph looks like this. It's and at 0, it's undefined. So at x equals 0, you get a jump discontinuity, not a vertical asymptote. 9, y equals e to the 1 over x. And so when x equals 0, you get e to the infinity, which blows up. So at x equals 0, you have an infinite discontinuity, vertical asymptote. So there you go. Number 11 says to use the function f defined and graph below to answer the questions. So I don't know. I went ahead and redrew the graph. So it's a piecewise function with a lot of different pieces. Lots of different pieces here. So graph looks like it's a parabola that's been shifted down 1 from -1 to 0. And let's see, it seems like that should be a solid dot there. And the graph kind of looks like that. And I'm not going to graph the whole parabola like I usually would. From 0 to 1, it's going to be that line that has a y-intercept up 2 over 1. So this line, slope of 2. At x equals 1, the value is 1. So just a single dot. From 1 to 2, it's a line that starts up here at 4 and goes down 2 over 1, down 2 over 1. So it kind of looks like that, but it's only defined from 1 to 2. It's open dot on both ends. And then from 2 to 3, it's 0 open dots. It's flat line. Okay, so that's the graph. So question A says, does f of -1 exist? Yes, it exists. The value of the function. The value of the function, f of -1, is 0. Okay, part B says, does the limit as x approaches -1 from the right side f of x exist? From the right side, yes. From the left side, no. The limit, so the answer is yes. And we could support our answer by showing what it equals. From the right side, it equals 0. Okay, C says, does the limit as x approaches -1 from the right of f of x equal the value of the function in -1? Yes. We just showed that they're both equal to 0, right? So let's see. So yes, they both equal 0. D says, is f continuous at x equals -1? Yes, it's continuous up to that point. It ends at that point. So I don't know. It's kind of a tricky question. I'd say no on that, but so that's 11. And then we're going to jump to 19. Now, in these problems, it says part A, find each point of discontinuity. Which of the discontinuities are removable? Give reasons for your answers. So, piecewise function. Now, I think the easy way is to just plug that point in and see what happens. 3 minus 2 is 1, 2 over 2 plus 1 is 2. They're not equal to each other, so there's a jump. So there is a discontinuity there because they don't meet each other. Plus, there's just a hole there anyway, so for sure there's a discontinuity. Secondly, there's a jump, so it's not removable because it's a jump. And the one-sided limits are different. If they were the same, then we could plug the hole. If there was a hole, which there was. Okay, so that's 19. 20, piecewise function. 3 minus x, 2, x over 2. X is less than 2, x is equal to 2, x is greater than 2. So I'm going to say, well, what's happening is we approach 2 from both sides. And so we get 3 minus 2 is 1, and then it's 2 add 2, and then it's 2 divided by 2, which is 1. So these agree with each other, but there is a jump that fills that hole. So it's A equals, so the discontinuity is at x equals 2. It is removable because we could reassign the value f of 2 to fill the hole. Okay. And then 21 function 1 over x minus 1. x cubed minus 2x plus 5. So the issue is at x equals 1. So I'm going to kind of do what I've done here. So, well, if we plug 1 in, what happens? We get 1 over 0. We're approaching 1 from the left-hand side. So it's less than 1, so it's actually negative infinity. And then on the other side, we're getting negative 1, we're getting 4. So these are not equal to each other. They're not approaching the same value. So there is a discontinuity x equals 1. It's not removable. I mean, the worst thing about it is that there's an infinite discontinuity. On one side, it blows up. So 22 f of x equals 1 minus x squared and 2, and x doesn't equal negative 1, and x equals negative 1. So this one's kind of a interesting piecewise. So it's defined everywhere as a parabola shift down, upside down, or shift up, upside down. But then at negative 1, it just has a different value. So we could, kind of illustrate what's happening here and say, well, on the parabola, it would be 0. But then at x equals negative 1, it's 2. So these aren't the same. So there is definitely there's a hole with a jump, right? So x equals negative 1. There's discontinuity. It is removable, because we could just change that. We could say, well, let's just assign f of negative 1 equals 0, or just get rid of that condition and just let it be a parabola the whole time. And then it doesn't have to be piecewise. 23, instead of giving you a piecewise function defined, they're giving you a picture of one. So I'm just going to rewrite that real quick. It's pretty simple. And so it's at 1. There's a dot. Here there's a dot. There's an open dot. Here there's an open dot. So it kind of looks like a parabola. And then solid dot, 1 to 2. All right, so where are there discontinuities? Well, specifically at x equals 0 and at x equals 1, there's a jump. Okay, and then of course all the points not in the domain. The graph just doesn't exist there, so we're not going to say it's continuous. So those are places where it's not continuous. X equals 0 is removable, right? And so we could just either, assign f of 0 equals 0 so that there's no jump anymore. X equals 1 is not removable. Because there's a jump. The one-sided limits are different. Okay, so there you go. All right. So we're going to go to problem 28 and 29. The directions say, give a formula for the extended function that is continuous at the indicated point. So, in other words, you're kind of like fixing the hole. So at 28, the function is sine of 4x over x. And so then at x equals 0, what happens at x equals 0 is there's a hole in this graph. And remember, we could figure out what the limit's supposed to be. So, well, you'd have to put a 4 here. You have to put a 4 here, and then that's going to go to 1. So we want it to equal 4, right? We want it to end up being 4 because that's what's going to be left. This is going to be a 1. And so to write this function, we could say, well, it's sine of 4x over x everywhere except for x equals 0. But then at x equals 0, we're going to fill the hole, right? And then 29 they're saying, well, the issue is going to be at x equals 4. Of course it is. It's going to be 0 over 0, right? And that might be because there's a hole. So you think, well, can we factor this? And you might say, oh, that's factored already. But we could think of that as the square root of x squared minus 2 squared, and think of it as the difference of squares. And then there's a hole in the graph. So then the way we fix this is we just redefine the function as the function without the hole, that it behaves like the rest of the time for everywhere. So that fixes it. 47 says find a value for a so that the function is continuous. So you're given a piecewise function, and the issue is at 3. So I'm going to just plug 3 in. Say, okay, well, this would be 3 squared minus 1 would be 8. And this would be 6a. And for this to be continuous, they need to be equal to each other. So I'm going to set them equal to each other and solve. So a should equal 4/3 for this function to be continuous. 48, find the value of a so the function is continuous. Same kind of problem. So 2x plus 3 for x is less than or equal to 2, and ax plus 1 for x is greater than 2. And so I'm going to do the same kind of thing. I'm plug 2 in and get 7. And plug 2 in and get that. And then these should be equal to each other. So I'm going to set them equal to each other. Subtract 1 from both sides. Divide both sides by 2. A equals 3. Okay. 49, same kind of question. Find a value of a so the function is continuous. I might get rid of a couple of these problems. They're all very similar. So same kind of deal here. So that's going to be 3. And that's going to be a minus 1. And they equal each other. So a minus 1 equals 3. So a equals 4. And 50, same deal. Piecewise function. X squared plus a, x cubed, x less than 1, x greater than or equal 1, plug 1 in, and we get a plus 2, and we get 1, and these got to equal each other to be continuous. So a plus 2 equals 1, so a equals negative 1. Okay. 56, 57, 58 were some multiple choice. So 56 says, on which of the following intervals is the function f of x equal to 1 over the square root of x not continuous? Well, we could just figure out, where it is continuous. So x can't be 0. X also needs to be positive, right? So x needs to be greater than 0. Okay, if x is less than or equal to 0, it is not continuous. So look at the options. A says 0 to infinity. Well, that's fine. B says 0 to infinity, including 0. No, that's not fine. So this is probably your answer. C says 0 to 2. Well, it is continuous on 0 to 2. D says 1 to 2. Well, it is continuous on 1 to 2. E says 1 to infinity inclusive. Well, it is continuous on all those. So pick the one that violates the rules. 57, which of the following points is not a point of discontinuity? Not point of discontinuity. For the function f of x equals the square root of x minus 1. So same thing. I'm going to say, well, the inside needs to be greater than or equal to 0. So it means x needs to be greater than or equal to 1. So this is what any point there should not be a point of discontinuity. So they have option A, x equals -1. No. That is we're looking for the one that's not. That one is a point of discontinuity. B, x equals -1/2. Yes, that's discontinuous. C, x equals 0. Also problem. D, x equals 1/2. Also still problem. E, x equals 1 is not discontinuity. These are all discontinuities because they're not in the domain of the function. Okay, 58. Which following statements about the function f of x 2x1 -x plus 3. So I'm just writing the problem now because I think that's helpful. So which of these statements is not true? So we're looking for something that's not true. Not true. So A says f of 1 does not exist. Well, that's not true. F of 1 does not exist is not true. It exists. It might not be continuous. It might be a jump or something like that. B says the limit as x approaches 0 from the right side exists. 0 from the right side, that's true. 2 from the left side, that's true. 1, approaching 1 from both sides does give you the same value. Both sides agree, so that's true. Anyways, A is the one that's not true. 59, which of the following points of discontinuity is not removable? So they give you this function. I think it's already factored for you. So if it's a whole, then it is removable.